Hello viewers, welcome back to my YouTube channel. If you are new to this channel, click on the subscription button and turn on the notification bell so that you never miss on an important update. For our old subscribers, thank you for staying tuned. Today, we are going to look at mechanics and we want to look at how we solve problems that are involving collision. We want to see how we solve different problems involving what? Collision. Don't forget, collision is what? Is bound by three basic principles. The first one is the conservation of linear momentum, which says that what? The linear momentum, the total momentum before the collision must be equal to the total momentum after the collision. Also, the second principle that is binding collision is the conservation of kinetic energy. That is, the kinetic energy before collision must be equal to the kinetic energy after collision. And also, the third principle that binds collision is the coefficient of restitution, which is the ratio of the velocity of separation to the velocity of approach. The ratio of the velocity of separation to the velocity of approach. So, look at this question, for example. Let's see how we solve this, how we analyze this using the same principle of what? Collision. Don't forget, we are interested in three things. The first one, the conservation of what? Momentum, that is linear momentum. The second one, the conservation of kinetic energy. And the third one, the coefficient of what? Restitution. So now, in this question, we are told that a 4 kg body moving with speed 10 meters per second collides elastically. It collides elastically with a 6 kg body that is at rest. The first question here, we are told to obtain their final speeds. That is, we want to know the final speeds of the colliding bodies. The second question here, we are told to calculate how much energy is lost. We want to know how much energy is lost. So, the first thing is to analyze that question. How do we analyze the question? So, let's draw our diagram to interpret this question. So, the first one here, a 4 kg body. So, let's assume this was the first body having what? The mass is 4 kilogram. A 4 kg body moving with speed 10 meters per second. The initial speed of the first body is 10 meters per second. Collides elastically with a 6 kg body at rest. This is what? 6 kg body. And it is at rest. For it to be at rest, that means what? It's not moving. So this dot on it shows that that body is at rest. It means that what? This what is moving along what? This side. For them to collide, it means the 4 kg mass is moving towards what? 6 kg mass that is at what? Rest. And also its own velocity is what? Because it's at rest, it has what? U equal to what? 0 meter per what? Seconds. Why? The body is what? Is at rest. Also, we are going to obtain their what? Final speeds. What happened to them after the what? Collision. This happens before collision. After the collision, let's see what happens. The first body and the what? Second body. The first body has what? Mass 4 kg, 4 kg, and the second body has mass 6 kg. Don't forget, after the collision, let's assume they both move towards the positive direction. Let's assume the two bodies move together towards the what? Positive direction. If this direction we have assumed is correct, we are going to know from the result, from the solution. If the results are positive, if they are both positive, it means we have assumed a good direction. But if the results are what? Negative, or one of them is negative, the answer is still valid. The only thing is that what? We have used what? A negative, a wrong what? Direction. For instance, if the final result of this is negative what? Minus something, it means that what? I will only change this direction to be what? Opposite direction. That's what. That answer still remains what? Valid. But we've assumed this, so let's assume that what? They move together after the what? Collision. The mass, this is what? The initial velocity of the two bodies, and what? For the Let's call this what B1 and let's call this what B2. I don't know their final speed. I want to know the final speed of the what of the colliding bodies. I want to know the final speed of the colliding body. So using our what our basic principles under what collision. Don't forget the conservation of what linear momentum. We say that what the linear momentum before collision must be equal to the linear momentum after the what collision. That is m1 u1 plus m2 u2 equals m1 b1 plus m2 b2. This is what the momentum of the body before collision, while this signifies the momentum of the body after collision. So after this, I know my what my first mass m1 to be 4 kg, my second mass to be what 6 kg, and also I don't know their final what speeds b1 and what b2. I don't know their what final speeds. If that is the case, the first mass is what 4 kg, so I'm having what 4 times the first velocity, which is what 10. 4 times 10 plus the second mass 6 kg multiplied by, because it's at rest, its own velocity is what 0. Why? That object or that body is at rest, equal to, here don't forget the masses remain the same both before and what after the collision, so there is no change in mass. So the mass will be what 4b1 plus the what of m2, we have what 6b2. Why? We don't know the values of b1 and b2. b1 and b2 are their what final speeds after the collision. What we've done here is that what we've applied the first principle, which is the conservation of linear momentum. So the second principle that we are going to look at, since the body is what is elastic, it means that what their coefficient of resistance is equal to what 1. Since the bodies are elastic, their coefficient of resistance equals what 1. So using their what coefficient of resistance, don't forget, for me to get the coefficient of resistance, it is simply the ratio or the velocity of separation. The coefficient of resistance given as E equals what? The ratio of velocity of separation V2 minus V1 over the velocity of approach, that is U1 minus U2, or I can write it as what? V1 minus V2 over U2 minus U1. What do we notice here? Anything that ends here must start here. Anything that ends here must what? Start here. Please take note of this. For elastic collision, the value of E is equal to 1. We've seen this in our last video, where we give them in form of what? Table. We've seen what happens to the what? Potential energy. What happens to the what? Kinetic energy. And also, what happens to what? The coefficient of restitution. So if that is the case, I'm going to what? Plug in my values. Don't forget, for elastic collision, the value of E is 1. This is what? Standard. So if that is the case, I can put this as 1 equals my V2. I don't know what V2 minus V1. I don't know what V1, because I'm looking for them. I don't know them yet. Divided by, what is my U1? Initial velocity of what? Of the first body, which is what? 10. Minus, what is my U2? For the second body, the initial velocity is what? 0. Why? That body is at rest. 10 minus what? 0. So if I multiply, I will notice that what? 10 times 1 gives us what? 10 equals V2 minus V1. 10 equals what? V2 minus V1. The whole of this, I can call this equation 1. Why this? I can call this what? Equation what? 2. I can now solve equation 1 and 2 simultaneously in order for me to what? To get their what? Final speeds. That is the V1 and what? V2 of these colliding bodies. I can solve equation 1 and equation 2 simultaneously in order for me to get the what? The final speeds of the colliding body. So in doing that, permit me to clean this. In doing that, we are going to have don't forget, we've seen our what? Equation 1, and also we've seen our what? Equation 2. So let me write this equation 1 very well. My equation 1 give me, this is 40 6 times 0 is what? 0. 4 times 10 is what? 40. 40 equals 4v1 plus what? 6v2. See, now to arrange it in such a way that v2 will be what? On the same level. Also, v1 will also be on the same level. So this is v2. I can write what? 6v2 plus what? Plus 4v1. So these are what? Equation what? 1. These are what? Equation 1. So how to solve equation 1 and 2 simultaneously? How do we do that? We all know how to solve what? Simultaneous equation. Either we use what? Elimination method or we use what? Substitution method. Anyone that is convenient for us. So let's assume how to what? Eliminate v1. For us to eliminate v1, these are what? The first condition is that what? I should make their coefficient to be the same. This is 4, this is what? 1. Multiply this by 4, multiply this by 1. If we do that, we are going to have 4 times 10, 40 equals 4v2 minus 4v1. Also, this second equation, I want to multiply everything by what? By 1. I'm going to have 40 also equals 6v2 plus 4v1. So at the end of the day, what we notice, we have seen that some terms can what? Can cancel when we add this together. Plus 4v1 minus 4v1, they are gone. That means I've eliminated what? v1. 4v plus 4v1 are what? Negative 4v1. They are what? Gone. What is left? 6v2 plus 4v2. That gives me what? 10v2 equal to 40 plus 40 will give us what? 80. 10v2 equals what? 80. Therefore, my v2 equals what? 80 over what? 10. 80 over what? 10, which is what? 8 meter per what? Seconds. The value of v2 is what? 8 meter per seconds. Also, since we've gotten v2, we can go and use that value of v2 to generate our what? v1. I've gotten my v2 to be what? 8. So let's use that value of v2 to generate v1. From this equation, my v2 is what? 8. So 10 equals 8 minus v1. Let me write this very well. Since I've gotten my v2, so I have to get the value of what? v1. Don't forget 10 is here. 10 is here. So I have to get the value of what? v1. So that means 10 equals my v2 is what? 8 minus v1. So that this plus 8, when it goes to the other side, becomes what? Minus 8. 10 minus 8 gives us what? 2 equals what? Minus v1. So that v1 can be equal to what? Negative 2 meter per what? Seconds. What we notice? Our v2 is what? 8 meter per seconds is positive, and our v1 is what? Negative 2 meter per seconds is what? Negative. What does it mean? It simply means that after the what? Collision, the direction we've assumed for v1 is the what? Is in the opposite direction. Don't forget, initially they are like this. This is what? This is at rest. This is the 4 kg mass, and this is what? 6 kg mass. They are at rest. After the collision, initially we said that what? They moved to in what? In this direction. But we now notice that our v2 is actually positive. It means, and don't forget, anything positive means what? It means that what? It's going to the right. Since the arrow is going to the right, it denotes what? Positive. But for our v2 is what? Negative. So we've assumed a what? A positive direction, so that we can what? Reverse this direction. We can only what? We can reverse this what? Direction, so that the whole of this result will now be what? Equal to what? 2. This answer still holds. It is only telling us that what? That direction that we assumed before initially, we should reverse that what? Direction. So this is how we solve in terms of what? The first question that they said that we should find our final speeds. So we've gotten the final speeds of the colliding body. The second question, we are supposed to find the loss in kinetic energy. What is the formula for finding the loss in kinetic energy? Don't forget, under elastic collision, kinetic energy is also what? Conserved. Kinetic energy before collision must also be equal to the kinetic energy after collision. What are we trying to say? What are we trying to say? So let's look at this. I've gotten my what? my final speed, so it means what? The loss in what? Kinetic energy. So for the second question, I want to find the loss in what? Kinetic energy. Under elastic collision, we see that what? The kinetic energy before collision is the same thing as kinetic energy after collision. What is the formula for kinetic energy before collision? Half m1 u1 squared plus half m2 u2 squared equals to what? Half m1 v1 squared plus half m2 v2 squared. This is formula for what? Kinetic energy. Kinetic energy before collision should be equal to what? Kinetic energy after what? Collision. So when we solve for the two, to find what? The loss in what? In kinetic energy, it means what? The higher kinetic energy minus the lower kinetic energy. So let's put in our values. Don't forget, the first mass is what? 4. The first velocity is what? 10. This is 10. While this is what? 0. So this is 10, this is what? 0. So let's put in our values. We are going to have half the first mass, which is what? 4 times the velocity, square it. That's what? 10 squared, give us 100. Plus half the second mass, 6 times its own velocity, 0. 0 squared should be equal to half the first mass, 4 times v1 squared. The value of v1 we've gotten is what? Is 2. So 2 squared. That's what? 4 plus half the second mass, 6 times the v2. The v2 we've got is what? Is 8. 8 squared. So this will give us what? This half of 100, that's 50 times 4, that's 200. 200 joules. The whole of this is what? 0. On the left hand side, we have 200 joules. Let's what we have on the right hand side. On the right hand side, this is 16. Half of 16, that's what? 8 plus. So that's what we have here. So we have 8 squared. That's 64. Half of 6 is what? 3. So 64 times 3. What are we going to have? 192. This is 192. 192. So 192 plus 8. This will also give us what? 200. 192 plus 8 give us what? 200 joules. So therefore, the loss in kinetic energy is what? The kinetic energy before collision minus kinetic energy after what? Collision, or the bigger kinetic energy minus the smaller kinetic energy. What do we notice here? Since the value here is the same thing as the what? As the value here. It shows that what? There is no loss in kinetic energy. It shows that there is no loss in what? Kinetic energy. This shows that there is no loss in what? Kinetic energy. Why? The difference between them is what? 0. Meaning that what? There is no loss in kinetic energy. Okay, so this is another question. Still on collision. So in this question, they said a ball of mass 0.5 kg moving at 10 meters per second collides with another ball of equal mass at rest. If the two balls move off together after impact, calculate their common velocity. So in this second question, we are told that what? We are having two balls. One of the ball has mass 0.5 kg and it collides with another ball of equal mass 0.5 kg, but at what? At rest. So the speed here is 10 meters per what? Seconds. Here, because it's at rest, the speed is what? 0. So this is u2 equals what? 0. This is u1, which is 10 meters per what? Seconds. It collides with it at rest. So this is before the what? Impact. After the impact, we are told that if the two balls move off together, that means after the impact, they move off together. They move off together. So they move off together. So that this is the second ball. they move off together. So after the impact, you can use one to represent that. So the two balls move off together after the impact. So we want to calculate their what? Common velocity. Since they have the same mass, so don't mind my diagram, the masses are the same. So we have the same diagram. So here we have 0.5 kg. Don't forget, there is no change in mass. This is still remains what 0.5 kg. Since they have the same what mass. They have the same what mass. So let's assume the what final velocity of this is what v, and this one is also what v. Or let's say v1 equals to v and v2 also equals to what v. Since they move off together with the same velocity, that means the velocity of the what first mass and the velocity of the what of the second mass are the same, which is what v. That's their common velocity. We want to calculate that common velocity. So from our what basic principle in solving any question related to what collision, the first one is our what the conservation of linear momentum. The total momentum before collision should be equal to the total momentum after the what collision. That is m1 u1 plus m2 u2 should be equal to what m1 v1 plus m2 v2. This will give us what 0.5 times 10 plus 0 times anything. This gives us what 0. Why? u2 is at rest. Should be equal to what m1 v1 0.5 v 0.5 v1 is what v plus the second one we call it what also what 0.5 v. Why? They have what a common velocity. They have what a common velocity, which is what v. So that you can have half of 10 0.5 times 10. This gives us what 5. This gives us what 5 to be equal to 0.5 v plus another 0.5 v. This gives us what 1 v or v. It means that what their common velocity is what. Therefore, their common velocity equal to what 5 meter per seconds. 5 meter per what seconds. 5 meter per what seconds. Thank you. Okay. So the next question, still on collision. So the next question says a ball of mass 0.1 kilogram approaching a tennis player with a velocity of 10 meters per second is hit back in the opposite direction with a velocity of 15 meters per second. If the time of impact is 0.01 seconds, calculate the magnitude of the force with which the ball is hit. Calculate the magnitude of the force with which the ball is hit. So this is another way of what? Of solving problems related to what? Collision. Unlike the other examples, in this example, we are going to what? To calculate force, in which we are given the what? Time. So collision can also be related to what? Impulse. It can also be what? Related to what? Impulse. That is, if I draw the what? Let's analyze this question. If I draw the diagram, a ball of mass 0.1 kg. This is the mass of the ball. The mass is what? 0.1 kg. Approaching a tennis player. So that means for the ball to be approaching the tennis player, it means that at the other side, the tennis player is actually waiting for the ball. Because the tennis player is waiting for the ball, that means what? It has no velocity at that instant. Since the tennis player is what? Is waiting for the ball, it has no what? Velocity. A ball of mass 0.1 kg approaching the tennis player with velocity 10 meters per second. So the ball is moving with velocity 10 meters per seconds. And it hits back. When it what? When it gets to what? The tennis player side, it hits the ball back. That means it returns the ball in the opposite direction. It returns the ball in the what? Opposite direction. Don't forget, the tennis player is what? Is not moving. The tennis player is what? Is not what? Moving. But it returns the ball back in the opposite direction. Initially, the ball is moving towards the tennis player. who is what stationary. So on getting to the tennis player return back the ball in the opposite what direction to the what to the server. So that means the direction was changes. Okay, don't forget, we are not given the velocity of the what tennis player. Why? Because it's at rest, his own initial velocity is what is zero. Likewise, the final velocity is also going to be what zero. Why? That tennis player is what is at rest. But what happens? What happens to the what the level or the magnitude in with which he hits that ball back? Will it also be moving at that 10 meters per second? Let's see the question. In the opposite direction with a velocity of about 15 meters per what seconds. Initially, the ball is coming with what 10 meters per second. But when the tennis player waiting for the ball at the other side, when he hits it back, that means he hit the ball what hard in such a way that it now changes its velocity from 10 meters per second to what to 15 meters per what seconds. To 15 meters per what seconds. This is 15 meters per second. Okay, don't forget the mass remain what the same. 0.1 kilogram. The mass remain what the same. So here V is what? 0. Also V is what? 0. So that's what our diagram that illustrates that. So now we want to find what? Let's calculate the magnitude of the force with which the ball is what? Is hit. We want to calculate the magnitude of the force with which the ball is what? Hit. Don't forget, still under our collision problem, the first thing we need to do is what? To apply our conservation of linear momentum. That is, the momentum before collision was equal to what? Momentum after what? Collision. So when we apply that, let's see what we are going to have. So let's see what we are going to have when we apply that. So let's see what we are going to have when we what? Apply that. So when we apply that, we are going to have something like this. Don't forget, M1 U1 plus M2 U2 equals M1 B1 plus M2 B2. Okay, so using our what? The conservation of linear momentum, so we have this. So this will give us, we have our M1 U1. Don't forget, the of this is what is 0 plus 0 equals, so we have M1 B1, and the of the other side is also what? 0. Why? The B is what? 0, and also the U is what? 0. So therefore, for the second body, so therefore this gives us what? I'm left with M1 U1. When this goes to the other side, it becomes what? Minus M1 B1. So that something is common to these guys. M1 is common. M1 is common into what? U1 minus B1. U1 minus what? B1. And the whole of this is equal to what? Impulse. And impulse is given as what? Force times time. Impulse is given as what? Force times time. Since we are looking for the force, it simply means that we can write this as force equals to the whole of this divided by what? Time. So we can have this as the whole of this divided by what? Time. To represent our what? Force, which is the magnitude of the force we are looking for. So when we put in our values, let's see what we are going to have. The force mass, our M1 is 0.1 kg, 0.1 into our U1, the initial velocity is what? Is 10 minus our V1. Our V1 is now what? It moves what? Is 15. 15 what? Is it in the positive right direction or in the what? Negative direction? Because it changes direction, it's going to be what? Negative 15. Because it's what? It changes direction. Everything divided by what? The time. And we are given the time to be what? 0.01 from the question. We are having what? 0.01 to be equal to what? Our force. So when we solve this, minus minus give us plus 10 plus 15. That's what? 25. 25 multiplied by 0.1. This gives us what? 2.5. So at the end of the day, we are having our force to be 2.5 divided by 0.01. So what is 2.5 divided by 0.01? So this gives us what? 250 newtons. 250 newtons. So this is the magnitude of the force with which the ball is hit.